In this video, I want to show you how you can use this piece in a very basic way or in a very advanced way. This is a very versatile piece as far as these go, and I left mine disassembled just so that you could see all of the pieces. I do, however, want to give this page a title. I strongly recommend that for any page that you're doing. These are units of customary measure. I would take time to talk with students about what that means. Customary, imperial, all of the ways to describe this measurement system, and contrast that to the metric system that is used in most all of the world except the United States. But for the purposes of math here, I believe this is page 5. I do want to number my pages and add this to my table of contents. So pages 5 and 6 will be customary measurement. And again, you can use these pieces with very, very beginning students who are just learning to add. You can extend this all the way into functions for your algebra students, and I will show you how to do that. So you as a teacher decide how far you want to go with this, and you can literally pick examples from any of these. This will work. So this is a very versatile anchor piece that you can use with any level of student, just depending on what they know. I strongly recommend starting with something that students are familiar with. So I think probably one of the most well-known of these conversions is this one right there. That 1 hour is 60 minutes. So pick a conversion, whichever one you want to use, and then pose a question to your students. So for example, how many minutes are in 5 hours? I have learned through many years of doing this that it is very valuable to students to write the question out in words. So you notice I am not using the number 5. I'm spelling the word out. Give them as much practice as you can in translating the problems. Now it takes a little bit longer, especially if you're having the students to copy these with you. I would recommend giving them a page to put over here just to glue down so they don't have to copy all this. If you have advanced students that can copy without it being a laborious task, that is not necessary. But if you're working with very beginning students, I would print that for them. But here's how I would start. I'm going to assume that my student is learning to do long addition. So we're told in our anchor piece that let me go back and get it exactly, 1 hour is 60 minutes. So the first thing you want to do is help the student figure out the conversion to use. And you do that by finding the units in the problem. So we need the conversion that works with minutes and hours or hours and minutes. And you see that that is the one there, hours, minutes. So that's the relationship that we are looking for. So for my students who are learning to add, I would literally do it this way. 1 hour is the same as 60 minutes. Remember, I'm working with a student who's just learning to do long addition. So I would literally write this out. We're looking at 3 hours, and this is a habit that I need to break. I forget to put the S on there. My students learned to look for that, and they found a lot of joy in catching me on that. But in doing so, they learned to do it themselves, so it was not time wasted. Okay, so this is where that long addition comes in. So if 1 hour is 60 minutes, I would have my students do this on scrap paper. I'm going to erase this, but 60 plus 60 is 120. So I would have them write it out on scrap paper. You could also use this as an opportunity to teach them the calculator. For 3, I would have them to write it 3 times. We're talking about first grade material here. Most of our students are not going to be at this basic level. And I will not torture you by doing each of these. 4 of them would be 240. I would encourage them to write the word minutes. It does teach them to spell. It also teaches them to follow through with units, because that is important in word problems. You need to keep up with your units. And then 5 hours, of course, is 5 times 60, or 300 minutes. And I've given away my next step. Okay, so this would be for the student who is learning basic addition. You could also teach this to the student, if they're ready for it, who's learning long multiplication. So 1 hour is 60 minutes, 60 times 2 for 2 hours. And I would teach them the mental strategy of bring down the 0 right here. And 2 times 6 is 12. If you had 60 times 5, bring down the 0. I had mine to color it in so they could keep up with it. And then 5 times 6 is 30. In case you wanted to do 10 hours, you could use the same mental math strategy, where you would have them to bring down 2 zeros. And then 6 times 1 is 6. I found that students catch on to this remarkably well. If you teach them to bring down the zeros. The reason I have them to color the zeros is because of this right here. I don't want them to confuse this 0 with this one. That blue one there is part of the 30. So we want them to be able to mentally distinguish the zeros. But either way, you can use addition or multiplication to build this set of data. If your students are ready to understand ratio and proportion, you could absolutely teach them using that strategy. So with my students, I always taught them there's actually an anchor piece that fits this model, where we look for a known ratio. Sorry, can tell I haven't done this in a while. We look for a word ratio. We look for a known ratio. And then we are looking for the unknown piece. And so I taught them to set up 3 fractions, ratios, set them equal because we're dealing with proportion. And the word ratio comes from the anchor piece. So the word ratio is going to come from this part. This is the way I taught nursing students to learn this method, and it worked beautifully. So the word ratio is 1 hour, 60 minutes. Okay. That happens to be the known ratio that we're using to solve this problem. We are not given another ratio. So you can copy it here if you want. There are times that you will be given a different known ratio, but that word ratio is always the same. So in this case, I'm still working with 1 hour and 60 minutes. Another example of this might be if someone is driving, well, let me just not even go there. All right, so the unknown comes from the problem where we have 5 hours. And so I bring that down, making sure that students know that I am supposed to line up those like units. Hours on top, minutes on bottom, or vice versa. But the unknown piece in this problem is the number of minutes here. And then I tell them to solve the proportion. You need to multiply the two that you can. So we would say 60 times 5. Again, I would use that mental math as much as possible. 5 sixes are 30. And then you divide by the number, I call that a peanut. And you divide by the number that's not in the peanut. It sounds silly, but it works. So in 5 hours, we are looking at 300 minutes. So this is quite a leap from the basic addition or the basic multiplication. Again, it just depends on the academic maturity of your student. If students are good with that, you can take this a step further by setting up a table. And I like to teach students horizontal tables first. I'm not really sure why. It just always seemed to work better with my students, but you certainly don't have to do this. I would draw out a table, and we're going to set 1, 2, 3, 4, 5 sections there, in addition to that label section. So for this one, we're going to be comparing minutes to hours. We know that, let me do it the other way, simply because that's the way it's written here. I've done hours to minutes. It doesn't matter mathematically, but just to keep my students following what I'm doing, I would keep it consistent. Okay, we know that in 1 hour, there are 60 minutes. In 2 hours, there are 120. In 3 hours, there are 180. In 4 hours, there are 240. And in 5 hours, there are 300. And this table could carry on to infinity. Okay, so you could leave space out there. Academically mature students can usually go directly to this table without having to do any of this math. That is a very good thing. When they can do that, they're ready to start understanding a little bit about graphing. And to help them with that, I would set up a vertical table, commonly known as an input-output table, and leading them a little bit closer to that algebra that we love, that I love. So in this form, okay, we're going to use the same format of hours and minutes, where we have 1, 2, 3, 4, 5. And again, that same pattern. The numbers don't change because the math doesn't change. The addition doesn't change. This all goes back to basic addition. All of math goes back to those 4 operations in some form. So help students make this connection, and then you can start adding in those function words like input, output, domain, and range. All of those good words that we can use. All right. And then finally, you can even substitute X and Y and graph this data on a standard line graph. And I would use some dotted paper or gridded paper, something to help students be able to handle that graphing. Draw your x-axis and your y-axis. And on the y-axis, we're going to be plotting minutes. On the x-axis, we are going to be plotting hours. You can even talk about dependent and independent variables here. That the number of minutes determines the number of hours, or vice versa, depending on how you graph this. Our hours are increasing 1 every time, so that gives you your scale. 1 hour, 2 hours, 3 hours, 4 hours, 5 hours. And I think I'm going to erase this because I just thought of something else I can show you here. We can calculate slope based on this data. On your minutes, we're gridding by 60. Each interval is 60 minutes. So we have 60, 120, 180, 240, 300, and then on to infinity in both directions. And of course, I would show students the 0 mark. So when 0 hours have happened, 0 minutes have happened. So you could even put a point there to say that when the minutes are 0, the hours are 0. When the minutes are 60, the hour is 1. When 120 minutes have elapsed, 2 hours have elapsed. When 180 minutes have elapsed, 3 hours have elapsed. 240 is equivalent to 4 hours. 300 is equivalent to 5 hours. And I can see a beautiful linear function emerging here. So at this point, I would help my students learn to graph. I would tell them this is called a linear function because it's a straight line. It has a positive slope. You could throw in all of those terms, begin to introduce functions here. And then for your very advanced students, you could actually go ahead and calculate slope. So slope is defined in shortcut terms as rise over run. The formula is y sub 2 minus y sub 1, or the change in rise over the change in run. Now, before I would even go there, I would help my students to see this stair-step effect here. So let's see if we can draw this in. So here, when I run 1, that's too big. When I run 1 unit, I rise 60 units. Okay, so this is point 160. Okay, and let me not put it there. It has been a very long time since I've done this, so I've forgotten. I need to keep my units here so that you can see the next stair in the steps. Okay, so I'm going to run another one. So that's 1 over, up 60. And there, let me try not coloring it with that thing. Let's do it this way. Here's another one of my stair steps. So again, the stairs are exactly the same size. The steps are. I went over 1 and up 60. So this time I'm over to 2 and up to 120, and I did it again. Maybe on the next one I'll get it right. Okay, so then we are going to run one more unit and increase another 60. So that puts us at 180. Three 180, and you can see yet another of those nice even steps. And I even talked to students at this point about what would happen if we built stairs, a set of stairs with steps of different sizes. Can you imagine walking upstairs when the steps were different sizes? So engineers use this concept. We need to set our slope, decide on how steep we want the stairs to be, and then make sure that everything slopes the same. It's very much common sense. If the slope changed in the middle of the stairwell, I would fall. Okay? So use the concept of the familiar. Whatever students can relate to, help them to see that in these terms. Okay, mathematically, let's calculate the slope. Let's figure out what slope is. So to do that, I'm going to pick 2 of these points. I'm going to let this be x1 and this be y1 and this be x2 and y2. And I personally had to label those or I got them mixed up. So I shared that with my students. Go ahead and label the 2 x's and the 2 y's on the 2 points you want to use. You can use any 2 points. Personally, I would have picked this one, 0, 0, and 160, because those are the smallest numbers. But you can use any 2 points that you want to use. Okay, so I've got my slope formula ready to go over here. So m, or slope, is y sub 2 minus y sub 1. Now don't panic on me. X sub 2 minus x sub 1. And I know that looks weird. So that's going to be 120 minus 180. That's a negative 60. 2 minus 3 is negative 1. And negative 60 divided by negative 1 is positive 60. So the slope is 60 on this particular graph. And that makes sense to me because of this. When x is 1, y is 60. And so that confirms the idea that my slope is 60, which is the rise, over the run. 60 over 1 is 60. And it doesn't matter where I do that. If I do it at 180 over 3, or let's go on up here, this would be 4 and 240. So if I do rise over run, what do I get? 60. because the slope of that line does not change. All right, and then the last thing that you could do, if you were so inclined, is to write the equation for this line in slope-intercept form. So that would be y equals mx plus b, where you know x and y, slope is m, b is the y-intercept, or where does that line touch the y-axis. And in our case, that's happening only at 0. So we'll put that in for our intercept. So y equals 60, that's our slope, x plus 0, or y equals 60x. And that happens to be the equation of this beautiful line right here. Y equals 60x. So just by taking that very basic equivalence, and you could do that for any of these equivalents, I can teach basic addition, basic multiplication, ratio and proportion, tables, input-output tables, graphing, slope, linear equations in slope-intercept form. So you can take this material and make it as easy or as complicated as you need to for your students. This is a very, very good little anchor piece that you can do lots of things with. If your students are level 1, then you would not want to go into slope. But if your students are level 5 or level 6 and they're getting ready to take the ASVAB or the HiSET exam or the HESI exam, they can understand these concepts. HESI doesn't even need this much advanced. They just need the basic conversions. So you need to know what your students' goals are and what their abilities are. And then as you are building their mathematical knowledge, link it back to things they already know. Say, okay, guys, you know how to do this part, whether it's by addition or multiplication. So we can do this part. We can set up a table. You could have them to continue the table, and then help them understand ratio and proportion. And before you know it, because you're anchoring back to familiar things, they will be able to comprehend this more advanced stuff, which really may even go beyond what they need to know. So I will hush now. You can tell that I really enjoy this. I hope this piece is useful to you, and I'll see you in the next video. Bye-bye.